In a residential garage with only one circuit, an on/off single-pole switch is indeed needed to kill the entire power without having to go back to the breaker. This requirement stems from electrical safety standards and building codes designed to ensure that occupants can quickly and easily de-energize the electrical system in the garage, especially in emergency situations. The purpose of this disconnect is to provide a readily accessible means to cut power to all devices and outlets within the garage, improving safety during electrical work, maintenance, or in the event of a fault. The installation of a single-pole switch as a disconnect is generally a straightforward process, but it must comply with local electrical codes and regulations. Firstly, the switch should be rated for the voltage and amperage of the circuit it is controlling. Typically, residential circuits are 120 volts or 240 volts, and the amperage rating will depend on the breaker size protecting the circuit, usually 15 amps or 20 amps for general-purpose circuits. Secondly, the switch should be installed in a readily accessible location within the garage. This usually means near the entrance or another convenient spot where it can be easily reached. The height of the switch should comply with local codes to ensure accessibility for all users. Thirdly, wiring the switch involves connecting the incoming hot wire from the breaker to one terminal of the switch and then connecting another wire from the other terminal of the switch to the rest of the circuit in the garage. The neutral wire is typically not switched but is connected directly to the neutral busbar in the electrical panel and then to the neutral connections in the garage. The ground wire is also not switched but is connected to the grounding system. Fourthly, all wiring connections must be secure and properly insulated to prevent shorts or other electrical hazards. Wire connectors, such as wire nuts, should be used to ensure secure connections, and electrical tape should be used to insulate any exposed wires. It is important to use the correct size wire for the circuit amperage. For a 15 amp circuit, 14 American wire gauge wire is usually sufficient, while for a 20 amp circuit, 12 American wire gauge wire is required. Using the wrong size wire can lead to overheating and potentially cause a fire. The switch itself should be mounted in a suitable electrical box, which can be either plastic or metal. The box provides protection for the switch and wiring and helps to prevent accidental contact with live electrical parts. The box should be securely mounted to the wall or another suitable surface. After the switch is installed, it should be tested to ensure that it is functioning correctly. This can be done by turning the switch on and off and verifying that power is indeed being cut to the circuit in the garage. A multimeter can be used to check the voltage at various points in the circuit to confirm that the switch is working as expected. Local electrical codes often specify the exact requirements for disconnect switches in garages, including the type of switch, its location, and the wiring methods to be used. These codes are in place to ensure electrical safety and prevent hazards. It is important to consult with a qualified electrician or your local building department to understand the specific requirements in your area. There are several reasons why a disconnect switch is important in a garage. Firstly, it provides a convenient way to energize the electrical system for maintenance or repairs. Instead of having to go back to the main electrical panel to turn off the breaker, you can simply flip the switch in the garage. This saves time and effort and makes it easier to work on electrical projects safely. Secondly, a disconnect switch can be a lifesaver in emergency situations. If there is an electrical fire or other hazard in the garage, you can quickly cut power to the entire circuit, reducing the risk of electrocution or further damage. Thirdly, the disconnect switch allows for better control over the electrical system in the garage. For example, if you are going to be away for an extended period, you can turn off the switch to conserve energy and reduce the risk of electrical problems. Common mistakes when installing a garage disconnect include using the wrong type of switch, using undersized wire, making loose wiring connections, and failing to properly insulate the wiring. These mistakes can lead to electrical hazards and should be avoided. It is always best to hire a qualified electrician to install the disconnect switch to ensure that it is done correctly and safely. Another aspect to consider is the type of switch that should be used. While a single-pole switch is commonly used for disconnecting a single circuit, a double-pole switch may be required in some cases, especially if the circuit involves 240 volts power. A double pole switch disconnects both hot wires in a 240-volt circuit, providing an extra level of safety. The National Electrical Code (NEC) provides detailed guidelines for electrical installations, including requirements for disconnect switches. Article 210.8 discusses the requirements for ground fault circuit interrupter (GFCI) protection in dwelling units. Garages typically require GFCI protection for all 125 volts, 15 amps and 20 amps receptacles. Article 225.31 requires that a means be provided to disconnect all ungrounded conductors that supply or pass through the building or structure. This disconnect must be suitable for use as service equipment. Article 230.70 1 states that the service disconnecting means shall be installed at a readily accessible location either outside of a building or structure or inside nearest the point of entrance of the service conductors. Article 404.8 specifies the location requirements for switches and states that all switches and circuit breakers used as switches shall be installed so that the center of the grip of the operating handle of the switch or circuit breaker, when in its highest position, is not more than 6 feet 7 inches above the floor or working platform. When choosing a location for the disconnect switch, consider factors such as accessibility, visibility, and protection from damage. The switch should be located in a place where it can be easily seen and reached, even in low light conditions. It should also be protected from physical damage, such as being bumped or knocked over. Consider installing the switch in a protective enclosure to prevent accidental damage. In addition to the disconnect switch, consider installing other safety devices in the garage, such as smoke detectors and carbon monoxide detectors. These devices can provide early warning of fires or carbon monoxide leaks, giving you time to evacuate the garage safely. Regularly inspect the electrical system in the garage to identify and correct any potential problems. Look for things like frayed wires, cracked insulation, and loose connections. If you find any problems, have them repaired by a qualified electrician as soon as possible. When working on electrical projects in the garage, always take precautions to protect yourself from electrical shock. Wear rubber gloves and safety glasses, and use insulated tools. Never work on electrical circuits while they are energized. Always turn off the power at the breaker before starting any work. In summary, a residential garage with only one circuit does indeed need an on/off single pole switch to kill the entire power, as it provides a necessary safety measure and complies with electrical codes. By understanding the requirements for disconnect switches and following safe electrical practices, you can ensure the safety of yourself and your family. Make sure you consult with a qualified electrician to ensure the installation meets all local codes and safety standards.